Topic: motion. Motion is defined as the change of position of a body with time. Types of motion: random motion. This is the irregular or haphazard motion of particles. Example: a drunkard moving aimlessly. Tiny particles suspended in air or water. 2. Rotational motion. This is the motion of a body around a concentric circle. Example: the motion of the blades of a fan, the motion of the earth round the sun, and the motion of the moon round the earth. Oscillatory or vibratory motion. This is the to and fro movement of a body about a fixed point. Example: the motion of a pendulum, the swinging of one's arm, and the movement of a spiral spring that is loaded. Position. This is the point an object can be located on XY plane when drawn on a graph. Distance. This is the gap between two given positions. Distance is a scalar quantity since it has no direction. Distance is only having magnitude but no direction. Displacement. This is the distance traveled or covered in a specified direction. It is a vector quantity because it has both magnitude and direction. Example: a vehicle traveling from Lagos to Port Harcourt. It must have magnitude of the speed and it must also have what? A direction. Speed. This is the distance covered with time, expressed as v equals distance over time, which is v equal to s over t. Velocity. This is defined as the rate of change of displacement. Velocity is a vector quantity, while speed is a scalar quantity. Acceleration. This is the change of velocity with time, expressed as a equal to v minus u over t. When we cross multiply, v becomes u plus at. This is called equation of motion 1. Uniform velocity. This is the equal change in displacement which brings about equal change in time interval. Uniform acceleration. This is the equal change in displacement which brings about equal change in time as well. Causes of motion. Force. Types of forces. There are two main types of forces. 1. Contact force. They require contact. Force field. They do not require contact. Example: when a magnet is drawing a nail, the nail is being drawn by the magnet by a field, which is called a force field. Friction. Friction is defined as the force exerted by two surfaces in contact which rub each other. Example: when you rub your palms together, that is friction. There are two main types of friction. Number 1, static or limiting friction. This is the minimum force that must be overcome before a body can just start to move. Number 2, kinetic or dynamic friction. This is the minimum force required to keep a body in constant motion without rotating. Laws of solid friction. There are 5 principal laws of solid friction. Number 1, it opposes the relative motion between the two surfaces in contact. It acts in a direction opposite to that of the motion. 3, it depends on the nature of the surfaces in contact, which means if the surfaces are dry, there will be higher friction. If they are wet, there will be lower friction. It does not depend on the area of surfaces in contact. 5, it varies directly with the normal reaction, expressed as F equals R, where coefficient of static friction is given as F over R. Advantages of friction. The following are the advantages of friction. 1, it enables us to walk. Without friction, it will be almost impossible for a human to walk, since there's always a frictional force between the movable joints. Without friction, we cannot sharpen our objects. Without friction also, we cannot walk on road because we will slide and fall. Disadvantages of friction. Friction leads to loss of energy. Friction leads to wear and tear. For example, if you have worn a slippers for a long time, check the bottom, you see that it have all worn out because there is always a frictional force between the slippers and the ground. Friction leads to loss of energy. Friction leads to the overheating of engines of automobiles. Methods of reducing friction. Number 1, lubrication. This is the method where we use oil, grease, and other lubricating materials to put on the movable part of machines to enable them move or slide on one another smoothly. Ball or roller bearings. Streamlining of a body shape. Circular motion. A stone tied to a rope which is wired in a horizontal or vertical circle. A satellite orbiting around the earth. The earth moving around the sun. The moon circling around the earth. The planet moving around the earth. All this shows circular motion. Centripetal force. This is called the inward force which keeps a body moving in a circular path. For example, when a vehicle is moving around a roundabout, there are two forces acting on the vehicle. One, the force preventing it from hitting the roundabout, and two, the force trying to push it away from the roundabout. So the one trying to push him inside is referred to as the centripetal force, and the one trying to push him outwards is referred to as centrifugal force. Centripetal force Ft is given as mv squared over r, where m is the mass of the body or object, v is the velocity or speed with which it moves around the circular path, and r is the radius of the circular path. Centripetal acceleration. This is defined as the distance covered or the change of speed of the vehicle around the circular path of radius r, which is expressed as v squared over r. Angular speed and velocity, omega and v. As the particle moves from P to Q, it covers a distance s, and an angle theta is moved, and r represents the radius of the circular path. The angular velocity omega is expressed as theta over t, where theta is expressed is the angle turned through with time, where s is given as theta over 360 times 2 pi r. When multiplied and simplified, our s becomes s theta r, where theta is the angle between the initial point and the final point, and r the radius of the circular path. Since velocity is equal to s over t, when you simplify, s becomes theta r. So v becomes theta r over t, where theta over t times r will give us omega r. So v is expressed as omega r. A mass of 200 kilograms is moving in a circular path of radius 12 meters with a uniform velocity of 100 meters per second. Find A, the centripetal force. B, the centripetal acceleration. Solution. Centripetal force Ft is given as mv squared over r. M is 20, v is 100, r is 12. So that will give us 20 times 100 squared over 12. The answer will be in Newton. B, centripetal acceleration is expressed as v squared over r equals 100 squared over 12. When simplified, will give you the answer in meters per second squared. A stone tied at the end of a rope 200 centimeters long makes 8 complete revolutions in 4 seconds. Find A, the angular velocity in radians per second, the linear speed v, and the distance covered in 3 seconds. Solution. 8 revolutions will give us 8 times 2 pi, which is 16 pi r. Since omega is equal to theta over time, which will give you 16 pi r over 4. When divided, will give you omega equal to 4 pi radian per second. B, linear speed v is equal to r times omega, which give you 20 times 4 pi r per second, which will give you 80 pi radians per second. Hence, the v becomes 0.8 meters per second. C, s equal to vt. Since v is 0.8 and the time is 3 seconds, so s becomes 0.8 times 3, which is 2.4 in meters. That brings us to the end of the topic, motion.